Step 1. Setup. You want to first set your global settings. All software packages will have a place you can set your units of measurement. In this case, KIC software has a nice feature where you can set the starting temperature where the profiler will automatically begin to collect data, 31 degrees C in this case. This prevents an entire profile from running in an off position. And here you select your hardware. Transmitter is selected. This will allow us to collect data live directly from the profiler to our software, especially useful when you have a long production run. Now we need to set up our paste spec. I'm going to search among a preloaded database and see if I can find mine. Here it is. I'd like to edit the manufacturer's spec since I know I have a component that cannot tolerate the spec's default upper limit. In this case, the peak temperature is set for 245. I'm going to change that to 243. Go ahead and give my new paste configuration a name. We have set our global settings and defined our paste. Now we need to define for the software our oven setup. Here is the paste we just defined, preloaded automatically. I'm going to associate one or more boards with my defined process. I can choose from numerous application templates. In this case, we are profiling a reflow process. Now I define my oven for the software. My oven in this example has 5 zones. I can manually define the oven set point temperatures for both top and bottom side heaters. Numerous ovens, however, can communicate with KIC software automatically transferring this information. I can also make changes to the zone lengths. In this example, I'm making an adjustment for a longer cooling zone. That's it, you're ready to profile. Unless you get a new oven, you need to change your solder spec, or the software does not automatically communicate with the oven. Now you're ready to run a profile, or baseline profile if your process is automated. Step 1 only needs to be covered again if you change your paste spec or if your oven does not directly communicate with the software. You may remember in global settings from step 1 we had a trigger temperature specified as 31°C. This works in tandem with the air TC on channel 1 of your profiler. You can see the air TC is mounted at the lead edge of the PCB to pick up the change from ambient temperature to oven temperature that will automatically trigger your data run. Go ahead, mount the remainder of your TCs. For most PCBs, 3 to 5 is the average number required. There are available on the market units that allow for a much greater number of TCs. If you'd like to learn more about TC prep and attachment, you can find videos on this subject on YouTube at the following link: www.youtube.com/user/profiling-guru. In this example, the profiler is loaded into the oven by hand directly onto the belt conveyor. If your oven does not have a belt, a common method is to use a scrap board or an adjustable carrier. If you are using an RF profiler, data will begin to populate your profile graph immediately. Or you can wait for the unit to exit and connect a data log cable to your unit. Some units, such as the one pictured here, have a special shielding allow you to handle the unit fairly quickly even when exiting a lead-free process. Now the unit has fully exited the oven, it will end logging data and begin analyzing your profile. In this example, I'm uploading profiling data using KIC 2000 software. I'll be using the Process Window Index, or PWI. If you are not familiar with PWI, you can find out more at Profiling Guru on YouTube, or simply enter Process Window Index in Wikipedia. Here is the familiar profile. The midsection represents the user-defined variables, the most popular being slope, soak, reflow, and peak. Your profile data is represented by both the actual readings as well as their equivalent Process Window Index, or PWI. Any values under 100 are in spec, 0 representing the center of your spec. Your current readings in this case show many out-of-spec values, shown in red. The beauty of PWI, your profile is represented by just one number, in this case 170%. Think of it like a chain. Your process is as strong as its weakest link. In this case, the worst PWI value represents how far you are in or out of spec. You also have predictive readings that look to improve upon your user-defined specs. The bottom half represents your current oven set points and conveyor speed. as well as the recommended changes to your oven and conveyor speed proposed by the software's prediction called KIC Navigator.